3 more than a number, x plus 3. 1/7 of a number. What did you guys say for this one? X divided by 7. X over 7. X divided by 7. Did anyone say anything else? Because if we're going to get technical, that of word is a multiplying word. So yeah, to do 1/7 of a number, we could divide it by 7, but how else could we do it? Yes, Raven. Yeah, what is it?
5.
No, this one. We're still talking about this one. There's another way to do this guy. Yeah, that's
1 up, Raven.
1 up. Sorry, Oliver? Yes, 1 over 7 times x. You bet. Raven, you want to do the next one? 5 more than 4 times the number? Reuben. Yes. 5 plus 4x from the Raven-Reuben combo. The product of 2 more than a number and 6. So this is very similar to one that I'd had on the board. If you want the product of 2 more than a number and 6, we're taking 2 more than a number, x plus 2, and 6, and multiplying them. The way to multiply them properly is to make sure that 2 more than a number is in brackets. The product of 3 more than a number and 4, I'll just start cranking these things out. This is going to be x plus 3 times 4. The 4 can go out front or out back, it doesn't matter. The product of 4 and a number plus 5 is that. 1/4 of the sum of a number and 3. So x plus 3, and then you're either multiplying that by a quarter, or you can write it as x plus 3 all over 4. Either of those is acceptable. The sum of 1/4 of a number and 3 would look like this. Either x over 4 plus 3 or 1/4 x plus 3, something that looks like that. No brackets in that one. 2 less than 8 times a number. It's going to be 8x minus 2. That's just going to be 8x. The product of 2 less than a number and 8, so that's going to be x minus 2 in brackets times 8. 8 could go in front or out bracket, doesn't matter. This is one I did with you guys in class. 2 numbers where one number is 1/5 the other. So one number is x, I'll call the other one x over 5, or 1/5 x. The ages of Angelou and Mary, whose total is 21 years. A plus M equals 21. The lengths of the jumps, if Jill's jump was 15 centimeters longer than Joe's. So there's 2 ways you could have done this one. Nobody asked you, Raven. So I had some students say, okay, Jill is J. So the 2 jumps would be J. And because Jill is 15 centimeters longer than Joe, that means Joe's jump is going to be J minus 15. So Jill's jump is the longer of the 2, so Joe's jump needs to be 15 centimeters less. Conversely, I had some people who said that Joe was J, and then Jill was J plus 15. This is Joe, and this is Jill. Depending on who you used to define your variable, your expression is going to be different. 2 numbers of a product, or 2 numbers with a product of 28. X times y equals 28. 2 numbers that differ by 10. X minus y equals 10. The number of grams in k kilograms is just going to be 1,000 times k. The value in dollars of x $2 bills is just going to be 2 times x. 1 bill is $2. X of them will be 2 times that. The number of hours in m minutes. What did you guys say for this one? So what you're saying is that if I had 60 minutes, 60 times 60 is 3,600. 60 minutes is 3,600 hours, is what you're telling me, based on that expression. Is that correct? Does that make sense? So Marcus, what should it be? M divided by 60. You take your minutes, you divide by how many minutes there are per hour, and I'll give you your hours. You can always do a quick test. The distance in meters of C centimeters, and there was 100 centimeters in a meter. This one's similar. If I have 200 centimeters, how many meters is that? It's 2. So how did we get there? We took our number of centimeters and divided by 100. Two numbers with a product of 76, so x times y equals 76. I'll skip those two and come back to them. Jessica is now twice as old as Joseph was 9 years ago. I'm going to call Joseph P, and Jessica's going to be J. So J, Jessica, is. This math word means equals. So Jessica's age equals twice as old as Joseph was 9 years ago. So we're going to take Joseph's age P, and what are we going to do with it? Sorry? We're going to take away 9 and do what with that? Well, she's twice as old as he was 9 years ago. We're going to double it. So that's what that expression should look like. 5 times one number, so 5x is equals 7 more than 8 times a number. So we're going to go 8 times another plus 7. So we got our expressions there. Anita's age doubled. So Anita, I'll call her A, times 2 is equals 5 years less than Lisa's age tripled. So 3L minus 5. We tripled Lisa's age, and then we took 5 years away from it. And then 3 less than 4 times a number, stop, ending with an easy one again, is that guy there. Now, some of you guys got hung up on, or most of you guys, got hung up on the consecutive integers and consecutive odds. With good reason. These are not easy if you've never seen this stuff before, but it was something fun for some of you to try. What are consecutive integers? Some of you said you have to look up integers. Integers are the plus and minus whole numbers. So -1, 0, 1, 2, 3, 4, 5. So consecutive integers are things like 4, 5, 6, -6, -5, -4, -1, 0, and 1 are all examples of consecutive integers. If I want all of the consecutive integers, did anyone I not help have an idea of how to proceed with something like this? Because I talked to a few of you I talked to. Ruben, you look like you have an idea. No? Okay. So we're looking for 3 consecutive integers. Let's start with one integer. Someone give me, if I don't know what the integer is, give me something to call it. Sure. So let's call x one of those numbers. I don't know what it is. It doesn't matter what it is. But x is one of those integers. To get from one integer to the next integer, what do we have to do? To get from 1 to 2, we add 1. So if the first integer is x, the second one is going to be x plus 1. And then to get to the next one, we're going to add 1 to this one. Well, x plus 1 is just going to be x plus 2. And this would give you all of the integers. Well, a group of 3 of them. You just have to figure out what the starting one is. Maybe the starting one is 7. Then this would be 7 plus 1, which is 8, and 8 plus 2, or 7 plus 2, which is 9. So 7, 8, and 9. So not, I don't think hard per se, but certainly different if you've never seen it before. Now the really gross one is the consecutive odd integers. So talk about consecutive odd integers. I want to start with my integers, x. Odds are, there really should be one other question, because the odds are really terrible. But so we're talking about all the integers. We don't want to talk about the odds. Let's talk about the evens. To make a number even, there is a relatively simple mathematical thing that you can always do to even a number. You know what it is? Dude, I did not talk to you on Wednesday. Can I take a number and make it even? Sorry? Multiply by itself? Multiply by 2. Yeah, double it. Any number doubled is even. 1 times 2 is 2. 2 times 2 is 4. 3 times 2, 3 is odd. 3 times 2 is 6. 6 is even. Doubling something makes it even. So if I want consecutive evens, I would just take my x, my unknown, and double it. This thing is an even number that I can start at. Once I have an even number to start at, how do I get to the next even number? Ooh, doubling it again would make it crazy. If this was 4, then double would be 8. There's an even number in between. Let's look at the evens. 2, 4, 6, 8, 10. How do I get from any one of these even numbers to the next even number? Add 2. So, just like this one, you get from one integer to the next, so it's adding 1 every time. So this one, to jump consecutive evens, we're just going to add 2. So we'll get 2x plus 2, and 2x plus, we can add 2 to this one. So this one's going to be 2x plus 4. So that's the evens, but that's not the question. The question is the odds. So we have to do something similar. We started with x plus 1, and x plus 2. This gave us consecutive integers. This gave us consecutive odds, evens, because doubling something makes it even. How do you guarantee oddness?
What?
Not always, because 2 times 3 would be 6, which is even. 3 times 3 is 9, which is odd. So multiplying by 3 is actually an alternate. Okay. 4 is 12, 5 is 15, 6, yeah, it's an alternate. The only way to guarantee oddness is to start with something even and then shift off of it. Because you know whatever's next to an even number has to be odd. So I'm going to start with my 2x. And how do I get to an odd? I could add 1. Instead of adding 1, what could have I done? Could have taken away 1. Well, there's 2. The odds go 3, 5, 7, 9, 11. How do you get from one odd to the next odd? Yeah, 2. Or take away 2. And that's what I'm doing here. 2x minus 1, if I add 2 to this, negative 1 plus 2 is positive 1. If I want to add 2 to this, I'm going to get 2x plus 3. Or if I wanted to take away, if I wanted to go that way, I could take away 2. I'd get 2x minus 3. Right now I have a list of 4 consecutive odd numbers. So if you've never seen it before, I didn't necessarily, that's why I love those 2 especially. I did not, if you didn't come up with those, don't feel bad. I didn't expect anyone to come up with those. I just threw them on there to play with and see how they went. Yes, Raven?
I don't.
Where was your hand? Waving for what?
I don't.
Okay. Okay. So this page just existed to get you guys starting to swap over your thinking from just straight math to bouncing back and forth between a verbal expression or a written expression and converting that into algebra. Now, what we're going to do is we're going to take a look at some problem solving. It's going to be great. Yes, it is going to be the best. The best time you've ever had doing anything ever. Here we go. And I mean that in all, no, I don't mean that in all sincerity. Okay, so I'm going to give you guys, we're going to do, how many examples do I have here? I have 3 examples here. I'm going to show you a collection of techniques, 2 specifically.
You can use whichever techniques you prefer, and we can go from there. So here we go. Find me this page. Yes, we're still in the booklet. Nothing's changed. Here we go. So, first example is this. 7 times a number is the same as 12 more than 3 times the number. Find the number. Okay, so the way this is broken down is a little bit further than perhaps we need to go, but we can start here. This is an expression that looks an awful lot like the sheet I just gave you. Before we even start converting this thing to an algebraic expression, what are some of the key words that we should identify here related to that chart I gave you on this page? What words in here tell us specific things? Okay, there's a times in here. We're multiplying two things. Sorry? There's a more than. More than means what are we doing? We're adding. And there's a really important word that is. Yes, Jackson, you extended it to the same as. Sure. Is the same as is an important, very important phrase. What does that phrase mean? Equals to. So we're going to be multiplying two things together. That is going to be equal to something. Well, it's going to be equal to 12 more than, times shows up here again, 3 times the number. Now, the word here, the, here we go breaking down English in math class. This word the is really important. What does it tell you about the number over here? The 12 more than 3 times the number. Yeah, it's the same as this number. If at first it's described as 7 times a number is the same as 12 more than 3 times the number. This word the tells you that these two are the same. And in math, if variables, or I'll say it this way, if unknowns, if I tell you that two unknowns are the same, how should we treat them? The same Jackson, the same variable for both. Absolutely. So now let's go ahead and there really is no picture or chart to make this make sense. So let's go and write out the equation. The first thing we're going to do is we're going to identify a variable, because now we actually have stuff to work with. The variable, I don't care what you want to call it. Jackson, you were the one that said that I need the same variable for this number and that number. So do you have a variable you like to work with? X, we like X. So X, and the way I want you to get in the habit of addressing these things is X equals the number. Whatever that number is, X is that number. And so now we're going to express the unknowns, or in this case, the one unknown, in the equation. We only have one unknown, so we can skip over part B here, and we're going to go straight to part C. Let's complete the equation. We only have one number. So 7 times a number, how am I going to write that? Yeah, that's just 7x. Is the same as is equal to 12 plus 3x. 12 plus is 12 more than, and 3 times the number is 3x. So now we've got an equation. This is the hardest part, is generating the equation that we then need to solve. This is something we've been solving for 2 weeks now. Ruben, Gershon, and Delgran, what are we doing? Bring your own. Ruben's learning math. How do I solve this thing for x? Because I have 12 plus 3x, we're going to take away the 3x on both sides. You betcha. to move all the variables over to the same side. Positive 3x minus 3x, gone. Leaves us with just 12 there on that right-hand side. 7x minus 3x is 4x, you betcha. And now I want to get x by itself. I don't want 4 times x, I just want x. We're divide 4 on both sides. 4's cancel, x equals 3. So that is, 3 apparently is the number. Let's check. Let's take this value, plug it back into our equation, and see if it works. Is 7 times 3 the same as 12 more than 3 times 3? Well, 7 times 3 is 21. 3 times 3 is 9. Is 12 plus 9 21? Yes, it is. So because this is true, this must be correct. And we were given it in words, so the number is 3. Boom. We are given it as a sentence. The answer then will be provided as a sentence. This is the procedure. Not bad, right? Sorry? Very bad?
Yeah.
Well, let's do a more interesting one. And this is bad, let's make it worse. If that was easy, let's make it more interesting. So I'll flip the page, let's take a look at this guy. This one is slightly different than the first one in that I now have, well, let's take a look. The sum of two numbers is 50. 3 times the smaller number is equal to 2 times the larger number. What is the smaller number? So how is this question different than the previous question? Oh, okay. There's 2 different numbers. There's 2 things we don't know here. Dilkaran, watch your language. Okay, so that's the question. We've got some important language here. We have the sum of 2 numbers is 50. I don't know what those 2 numbers are. I know that 3 times 1, the smaller of the 2 numbers, is equal to 2 times the larger. What's the smaller? So again, there's no picture or chart to draw. Let's identify some variables. Let's pick some variables. What don't we know? Get as specific as possible here. We don't know 2 numbers. So Oliver, give me some variables you like working with. Give me some variables you like working with to represent those 2 numbers. Sure, x and y.
Then I guess they both have to be.
They might work out that, well, I'm not sure that's true. It doesn't say anywhere that they have to be even.
Yeah, but if it's 3 times the small number has to be 2 times the
Yeah, I guess you could infer they have to be even. Because 3 times an even, yeah, you're right. I mean, that's at this stage not helpful, but you're right. So I've got 2 numbers, x and y. We know that the sum of them is 50, it says, and 3 times the smaller is equal to 2 times the larger. Because we are asked to specify smaller numbers and bigger numbers, I have to get specific here with x and y. What do I want x to equal? What do I want y to equal? I have 2 different numbers here. Well, if these numbers are 2 different sizes, one of those variables needs to represent the smaller variable, or the value. So which one do you want to represent the smaller value? Sorry? Well, 3 of you have said y, so we're going to go with y. So let's say, don't just say x and y are the unknowns, get as specific as you can. You know one has to be smaller. And it matters which one is smaller, because they specify that you want to multiply by the smaller. What you want to multiply by the smaller and what you want to multiply by the bigger. So x is going to be equal to the bigger number, based on what you guys have said, because you wanted y to be the smaller number. It matters which one we call. Now we want to express the unknowns, or one unknown in relation to the other unknown. So at this stage, I'm going to draw a line down the page here to the right. There are two ways to proceed with these kinds of problems. And I'll show you what I mean. What do we know about x and y as given to us in the problem? How are they related to each other? Brielle, you look like you have some guesses. Emma, did Brielle have some guesses? I'm pretty sure she did. What do you guys think? How are these two related? It's given to us up top here. X plus y equals? No. It says the sum of two numbers is what? So x plus y is 50. Okay, well, if the sum of these two numbers is 50, what I could actually do is I can rewrite one of these variables using the other one. If the two numbers have to add to 50, let's say I will keep y in there. Y is the smaller number. What is x going to equal if x plus y have to add to 50? I'll do it this way. If y is 20, x has to be what? Oh, yeah, sure, you can go straight to where I'm going, sure. Pause what Oliver just said for a second. What I was trying to get you guys to think was, if y is 20, x has to be 30, because 30 plus 20 was 50, or 30 is 50 minus whatever y is. Oliver just gave it to us. Because x plus y has to equal 50, that means that x, the bigger number, is going to be 50 minus whatever y is. So this then is going to be the relationship between our two values. Instead of having x and y now, I'm going to have two expressions with y. We know the bigger number, x, has to be 50 minus y. So all we did here is we stopped and said, okay, well, if the two numbers have to add to 50, that means that one number is going to be 50 minus the other number. So now we can use these. We can replace x. We don't need x anymore. We could say, well, the bigger number is going to be 50 minus y, and the smaller number is y. So we can go ahead and make our equation. What do we know happens to the smaller number? Well, it says 3 times the smaller is equal to 2 times the larger. The smaller number is y, so 3 times the smaller, 3y, is equal to, doesn't get any clearer than that, is equal to what? 2 times the larger. Well, the larger isn't x anymore. The larger now is what? 50 minus y. This whole expression is now what the larger number needs to be. So if I'm going to take this and I'm going to say, okay, well, the smaller, 3 times the smaller, is equal to 2 times the larger, and the larger is 50 minus y. That now needs to go inside a set of brackets, and now we've got an equation to solve for y. Because all we want is the smaller number. So let's solve it. What's my first step to solving this thing? What do I have to do to solve? Sorry, Oliver? Yeah, I got to multiply in this too everywhere. We've got 3y equals 2 times 50 is 100. 2 times negative y is negative 2y. Now what? Yeah. By doing what? We're going to add 2y, you betcha. Move the 2y to the other side by adding it over there. So we're going to get 5y equals 100. We want y, so let's divide by 5, y equals, sorry, 100 divided by 5? It's 20. So that is allegedly the smaller number. Let's plug it back in and check. 3 times 20 is 60. 50 minus 20 is 30, times 2 is also 60. So this is good. So this is one method to tackle a question like this. This step here, we did largely in our head. There was lots of thinking, well, for some of us. There was a certain degree of work inside the head that was done to come up with this relationship. There was another way to tackle something like this. Yes, Kerman? Hello? Excellent, thank you, sir. Okay, so I want to introduce you to something called substitution. Maybe this isn't an introduction, maybe you've seen this before. Substitution. What time does the bell ring for lunch? When it rings. I think it's 11:30. It's 11:25. So we have 25 minutes. Here we go. So substitution looks like this. It starts very similar. We say, okay, well, we've got two numbers. We've got a bigger, we got a smaller. This one is substitution is less thinking, more math. Some of you are like, I struggle to wrap my head around some of this stuff. Okay, cool. Stop thinking. Let's do more math instead. So what we would do at this stage, we'd say, okay, well, I've got, the first step is the same. I want to identify my two values. One is x, the bigger number. One is y, the smaller number. And I want to figure out what these things equal. Well, the sum of them is 50, so let's just write that down. If the sum is 50, it means I have to take my two numbers. I'm going to use a different color. I'll use brown. We're going to add these two things together. We're going to say x plus y equals 50. I'm just going to leave that there, let it sit for a second, and then I'm going to go back to the second equation and say, okay, well, 3 times the smaller number, well, we call the smaller number y, so 3 times y is equal to, okay, well, that's an equal sign. 2 times the larger number, well, that's just going to be 2x. So rather than doing a whole bunch of thinking at this step, I skipped that part and I said, okay, cool, I'm just going to write down, I have two sentences, I'm going to write down my two equations, here they are. X plus y equals 50 and 3y equals 2x. At this stage, we have a decision to make. In the method that is substitution, so we've got two equations here. What we need to do is pick an equation and isolate a variable. Doesn't matter which one. Sometimes one of them will be easier to work with than the other. Like there is often an easier option, but it really doesn't matter which you choose. It will work either way. So you pick an equation and isolate a variable. So let's pick an equation. Pick one of those two equations and then choose which variable you want to isolate for. Which one looks like the easier one to work with? Someone make a decision. I'll start picking on people. Ruben. Which of these two equations do you think looks easier to work with? That's all I'm going to ask you to do. No, what does your gut tell you? I'm looking for like a... Pick one. You want the bottom one? Okay, let's do the bottom one. Now, Ruben, you've picked the bottom equation. Now you need to isolate for one of the variables. You want to get one of these variables by itself. Doesn't matter which you choose. Do you want to get this x's alone or the y's alone in the second equation? Okay, so Ruben has picked equation 2, the second one, 3y equals 2x, and Ruben, you want to get x alone. So to do that, I've got 2 times x. What am I going to do to get x alone? I'm going to divide by 2. We're going to divide by 2, and we get x equals 3y over 2. Now what we're going to do is replace the isolated variable in the other equation, the equation we haven't worked with yet. So Ruben picked this equation 2. We isolated the variable. We said 3y equals 2x. We divide both sides by 2. We get x equals 3y over 2. What we're going to do now is we're going to replace the isolated variable, x, in the other equation that Ruben did not choose. So x plus y equals 50. So that's the one we're going to replace. Instead of writing x plus y equals 50, what we're going to do here is we're going to write, if x is equal to 3y over 2, this equation is going to become 3y over 2 plus y equals 50. We took this guy right here and we put it into the other equation where the isolated variable was sitting. And so now we've got an equation to solve. This equation, Ruben, in his brilliance, decided that he wanted to introduce fractions to give us some extra practice. Ruben, good choice. I was actually really hoping that that's the one you were going to pick. Well done. So how, because these are the kinds of questions so many of you screwed up on the quiz, how do I get rid of that fraction first? Multiply what by 2? Everything. This guy's getting multiplied by 2. This guy's getting multiplied by 2. And this guy's getting multiplied by 2. In the first term, the 2's are going to cancel, leaving us with 3y. Plus, well, 2 times y is just 2y, equals 50 times 2 is 100. Oh, look, we're at the same spot. We managed to get to the same spot we were at before. Because 3y plus 2y is 5y equals 100. We're going to divide by 5, divide by 5. Y is still equal to 20. What happened? I sped up at the end there. Yes, because 3y plus 2y is 5y. So you can either do a lot of thinking, be like, oh, how are these related? Okay, here's my expression, and do it up top here. Or this method called substitution is a really handy way to tackle things like this. And we still get our value. Let's do one more example this way and see what you guys come up with. Here we go. This question is very old. Back in the day, because phones don't come in 16 and 8 gigs anymore. The smallest that I could get when I went on Thursday for my Black Friday deal was 128 gigs, was the smallest one they'd offer me. So this is an old question. How much were phones when I was younger? I don't know. I don't know. I don't remember. It was a long time ago. It was 21 years ago. My first phone was 21 years ago. I don't remember what I paid for it.
How much was McDonald's?
I don't remember. 20 years ago, it doesn't matter. Okay, so a 16 gig phone costs $75 more than an 8 gig phone. Together they cost $725. How much is each? Okay, what are we looking for?
The price of each phone.
The price of each phone. So, let's give these things some names, shall we? Yeah?
Here's that answer.
Okay, hold on. Don't do it then. You're just showing off now. I know, we're gonna find out real careful. We're in a second here. We've got a 16 gig phone, we got an 8 gig phone. These are the things we want to find out. Let's call the 16 gig phone something. Sorry? B, okay. The 16 gig phone we're calling B. What could we call the 8 gig phone that relates to B? No, that relates to B. What do we know about the 16 gig phone and the 8 gig phone? The 16 is $75 more than the 8 gig phone. So what is the 8 gig phone going to cost? Well, it's going to be the cost of the 16 minus 75. Again, two ways you can do this question. What I'm modeling here is, rather than giving me two variables, B and G, for example, I could say, well, one of them is B and the other one's going to be $75, either more or cheaper, depending on how you labeled these things. You're right, you could have done it this way. The 16 gig phone we're going to call B. The 8 gig phone we're going to call G. I don't know. If we do it this way, if you introduce two variables, you have to use substitution. Because now we're going to have two expressions. We know that G plus 75 equals B. We also know that together they cost $725. So if together they cost 75, that's going to be the second equation. Together means, what am I doing mathematically? Together was one of the words we looked at. Together is adding. Raven, unless you have something positive to contribute and not just random stuff, please keep your just not useful. Not useful. Because I was asking you, Raven, what mathematical operation together meant. And you decided to say that together you were stronger.
No, we're stronger.
Just stop talking. Just stop. What? No, just stop. What you need to recognize is that together it means addition. So together they cost $725. That means over here, B plus G equals 725. And now you've got two equations that you need to substitute one into the other. Over here, we said, okay, well, the 16 gig phone is B. If it costs 75 more than the 8 gig phone, then the 8 gig phone is going to be B, that same cost, minus 75. Either way, we're going to get to where we need to get to. Over here, then, if I can say together they cost 725, I'm still going to add these two things together, but instead of B and G, I'm going to add B, the 16 gig phone, with B minus 75, the 8 gig phone. And together they add to $725. So doing it this way, if you can relate them with a single variable, it means you're only going to get one equation you have to deal with. If you decide to introduce two variables, now you're going to get two equations, and we have to do it what I made Ruben do a second ago. You're going to isolate one of the equations for one of the variables. You're going to plug that into the other equation and move forward from there. Are you asking about what the correct answer is?
No, but I'm saying that there's a much easier way.
What's the easier way?
You take the 725 minus the 75 and then divide by 2. That's the answer.
Well, that's what we're going to do right here. Actually, you're going to have to add the 75. You don't take away the 75. Well,
It's either way.
taking it away is going to give you the smaller price. Adding it is going to give you the larger price. Yes, but I'm not. Yes, that's true, but why? This is why, and I don't want you. The danger here is some of you guys are saying like, yes, I can see where this is going. My intuition is leading me somewhere. That's great. As soon as I make the question slightly more difficult and your intuition fails you, you need a method to fall back on. This is the method. So I'm going to group my like terms. B plus B is 2B. Minus 75 equals 725. I love that you guys have intuition, but you need to tie that to a method that works consistently. To solve this thing for B, we're going to add 75 to both sides. So 2B is now going to equal 800. We're going to divide by 2. We're going to divide by 2. And B is 400. So the 16 gig phone costs $400. So the 8 gig phone costs 75 less than that, 325. And these two numbers add to 725, so you're good. This is if you can do it with one variable. If you decided to do two variables, you've already got, so on this one, I want to model this guy. Don't distract people, Rabin. Brielle, don't get sucked into Rabin's ramblings. Just focus on what we're doing. So I've already got one equation isolated for one of the variables. So what I could do on this side, Dilkaran, please pay attention. I'm almost done. What I can do on this one, because this equation is already isolated, I can just take this, because this equals B, and put it in for B in the other equation. What we're going to get is that G plus 75 plus another G equals 725. G plus G, I'm going to group my like terms. That's going to give me 2G plus 75 equals 725. And now we're just going to solve this thing for G. We're going to take 75 away from both sides. I'll get 2G equals whatever 725 minus 75 is. That's going to be 650. I divide by 2, I divide by 2. G is going to equal 650 divided by 2 is 325. And we said earlier that G was the cheaper phone. So we know that the more expensive phone is $75 more. So 325 plus 75 is 400. I get the same result either way. It doesn't matter which way you choose to do it. What I don't want you to do is to just intuit it. Use your intuition to just blurt some values onto the page without having some method to back it up. Oliver, your easier way was just the second way to do the question.
Yeah, but it looks less complicated.
Yes, but this has a reason. This has something holding it up. If I make the question a little bit harder, I just have to keep tweaking things, and then your intuition will fail you. Eventually, I can hit that point. You just need to have a mathematically valid way to do it. Okay, here's what I want you to take a look at. We're going to start with some easy ones, and then Monday I'll give you some gross ones. I know you want to go home. So do I. Here we go. Let's start the first chunk. Let's see what you can do with the odds. Page 15 to 17 odds. Yep, there you go. The bell is going to go soon, but that's what I want you to work on. We'll have Monday and Tuesday to work on this stuff and review when you come back after the weekend. You've got the reviews. Those of you who were here yesterday, I would ask that you work to the bell.
Yeah, you got 30.
8 minutes. 6 minutes. No, I'm not letting you go to contentious room for 6 minutes. Okay. Oh. just finished saying, what's the bell?
That's what I'm doing.
If you did not get the review yesterday, here it is. Oh, sorry, hold on.
Why that guy say I'm wrong?
Okay, Ruben, if you or Raven, sorry, Raven, if you don't use this time to work, I'll give you lunch. You make up the time. No, use the time that is left.
One,
No, it's not gone yet.
4, 5.
Hey. You have to justify what you're doing with proper work. Yes.
No, Alex died for the ball, right? You saw that, right? Alex died for the ball, and then they weren't fighting for the ball, and then Alex got up, and then Ruben too, like, and then Alex also used and he's like,
Yeah. There's a couple questions I meant to tweet that clearly I forgot to tweet. Jackson, you don't use this time, you'll stay at lunch until you've made up the time. Where are you going? Why are you packed up? Yeah, sit down. What do you about what?
5 minutes, 5
40 minutes after it starts. Get your stuff out. I asked you to work to the bell. Lunch is always 40 minutes long.
No, short.
Shobit, have a good night.
You let him back up?
Yeah, I did.